right? Okay, so let me now give you definition. Till now I have explained you with my intuition, with my own examples, right? Now Python, of course, Python is object oriented programming, and OOP is generally based on real world objects or entities, right? Object or entities. Now it mainly focuses on objects. Now you are listening here new term which is known as classes. Now what will happen? How you create the object? For object you need some blueprint. For example, if you want to create a SUV car, you need the blueprint of SUV, what feature it will have. For that blueprint we keep all those blueprint in class. So class will basically define the structure of object, structure, its attributes, its methods, what it can do. All these things defined into class, and we create object from class. For example, class name is student. Now student can be multiple, right? For example, in our session Kamlesh is here, right? Hemant is here, right? So Kamlesh and Hemant are object of student class, and the definition of student, it is in form of class. So ultimately we are creating real world of objects, and objects are created based on class. How? I will show you how we can create, but class is a blueprint or its definition, and objects are real world entities, right? So in this approach, problem is considered in terms of objects. We solve each problem using object, not like using functions or writing simple code. We will try to solve this whole problem on the basis of objects. So OOP makes code reusable, as I told you earlier, modular. Your structure become much more modular, right, and easier to maintain. So that is why most of the company write code in OOPs. If you see C++, Java, if you know any of the programming language, it is a very good way to organize your code, reuse your code, and structure your code, right? So that is why OOPs is important, right? Now in OOPs we have object, as I told you. So object are generally known as instances. Instance of what? Instance of class. Class will have definition only, right? And definition or blueprint. Okay, now ultimate goal of this class and object is to organize the code. We also have few other properties like encapsulation. It means it will encapsulate all the details into single class, and it won't go outside that. So that is why it also help in the protection of data. It hides the information. We also have abstraction, means it will hide the complexity and it will simplify the uses. For example, ATM machine. When you do a transaction on ATM machine, right? So you will get your money, right? And money deducted from your account right? But do you know what is happening at the back end? What code they are running, how they are optimizing that code, how they are reading the data from database, how they are ensuring asset properties, how all these things they are doing, how they are maintaining. Inside this you don't know what is happening. So ultimately you are just seeing a window on ATM machine, and you are putting your ATM card into this, and you are taking money out of that money, and your ATM card is here, right? You are getting your money from here. So they simplified this, all the complexity, how it is happening, which API they are calling, in which table data is updating. They are hiding all the complexity. So this is known as abstraction. In OOPs also, when you create class, you hide all the complexity. You try to keep it simple for user. So abstraction means hide the complexity. Just like I have shown you example of ATM machine. You can see UPI also. What is happening behind UPI? You don't know which API they are calling, how they are doing authentication, how they are verifying OTP, how these transactions are happening within fraction of seconds. So all these things are happening in a smooth way. You are not feeling what is happening So they are hiding all the complexity and they are simplifying your work. For example, if you are doing stock trading, any one of you, if you done stock trading using Jarodha, right? In India we use app Jarodha. Jarodha have one app there, Kite. Similarly we have Grow, right? Most of people use Grow. Of course we have other, right? Upstock and all. These all, how they are simplifying your transaction. So the way they are simplifying it is abstraction, right? Another property is inheritance. Inheritance means, suppose you have a student class and from student you are inheriting some other class, right? For example, a student, a graduate, or a graduation student, right? Or post graduation, right? It means MCA, MSc, right? Graduation means your BA, BSc, BTech, right? So these are subclasses of this. These are subclasses of this. Similarly, if you see animal class, dog, right? Cat, or any other animal, okay? Elephant. All are, these are subclass. These all will have feature of animals. These all will have feature of animals, but all these have feature of animal, but they also have their unique features. So they are inheriting some property from here, right? For example, shape class has 2D shape, 3D shape, right? In 3D you have cuboid, right? In 2D you have square, okay, and you have rectangle, right? So you can see shape, you have some property of shape. 2D will have some details, square will have some feature of 2D, rectangle will also have. So this is your inheritance hierarchy. Just like your grandfather features are into your father and their features into son or maybe daughter, right? So your features are transmitting from one generation to other. Similar way, from one class, this is your parent class, right? This is your parent class, this is your child class. So we are transferring some feature from parent to child, and child also has your own features. Like for example, any one of you have some feature from your parents, your father and mother, right? But you also have some of your own features, right? The same way we have inheritance concept here, right? So inheritance offers reusability. Suppose some features are already implemented here, like animal walk, right? Walk feature is implemented here. The walk feature is same for each subclass or each child class, right? Similarly, another concept we have polymorphism. Poly means many. You can use one thing with different names, or you can use one thing from multiple ways. For example, I will show you what the exactly example is, but from same name, from same thing, you can have multiple things, right? Okay, or you can say same function, same kind of, with the same word you can do multiple things, right? So how we will achieve polymorphism, I will explain you in upcoming session, but try to understand the whole phenomena. This phenomena is coming from real world. In real world, everything is object. You, me, everything that we are using is your object, and we want to write code into form of objects, right? How we will write this code? Using class and object. Class will have all the definition. We will write only using class, and via class we create objects. So these objects are real world entities, and these objects will do all these things: encapsulation, abstraction, inheritance, and polymorphism, right? Great. So now, of course, class, right? Class are user defined data type. Till now we have seen list. Let me change the color, right? Because otherwise color will be same. We have seen list, tuple, dictionary, right? These all are predefined object, but you can also create your own object. For example, you want to create object stack, stack will have your array if you know data structure, plus one 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 more count or top element, which will say you on which value the top is. If you see, this is your stack, right? Suppose you have these three value 1 2 3, this is your top. Now what you want to do, you want to do push and pop are operation. Stack is a class, an array and the top value, these are your attributes, right? Okay, so class is your user defined data type. You can create your own data types. Class represents a set of objects. Why? Using one definition you can create multiple objects. For example, a student class may have multiple objects. Like suppose in this class we have 15 students, so 15 objects we will have. And class is nothing, just a blueprint from which objects are created. Ultimately we create object from class. So if we know how to create class, our 50% job is done in OOPS. The whole matter is about creating classes. If you create the class, you can easily create objects and everything. It is all about creating class. Not only 40%, 50%, it is more than that. If you understood how to make classes, how to use those classes, your more than 50% job is done. Right? Okay, one more thing. Class does not occupy space or memory. For example, you have created a list, right? So list has no memory. It does not have memory until you add some item into this. When you will add item like 1 2 3, then it will have some memory. Otherwise it won't consume any memory. List class is not consuming any memory. Only its object that you are creating, L is equals to this is consuming memory. So no memory is allocated when class is created. Memory is allocated when object is created, because each object have their own values, right? For example, I am a student, so suppose I am a student of PhD, right? So my status is class is PhD, my name is this, I in which subject I am doing, right? Suppose I am doing in computer science, right? So these are things. Suppose you are MTech student, so in which subject you are doing MTech in data science, MTech in cyber security. So these all information metadata will be inside the class, and when you create the object, that metadata will be into real world, and you will create the object and it will store your value into that object. So an object is a concept, abstraction, or a thing with the sharp boundaries meaning for an application. For example, a class is a car, right? An object is Zing, Alto, Centro, right? Your Mahindra Thar is also a car, but it is a different type of car, right? Or you can say some other car, SUV, any SUV car, right? Creta or anything, right? So car, now you can see some example here, right? Okay, let me also explain that. It will take a minute, right? So object is an instance of the class. Instance. We create object from class. So we say object is an instance of class. Object is a type of class, or a instance, it is really instantiating that class, right? That has some attribute and behavior. Behavior is your method, your function, right? Class consists of data members. Data members are nothing. Data members are attribute, because they keep data, and methods are methods, or you can say actions, right? So now I have already given you this example, right? For phone, the brand, model, color, battery, these are the properties. These are properties, attributes, or data member, right? Methods are your behavior, right? Your behavior, your functions, you can say, but generally we don't call this functions, right? We don't call this function, we call methods, right? Or its behavior, right? So method, or you can say action. Action is a good word, right? I have shown you this example also. Now let me show you some other examples. For example, dog. Dog has like breed, age, color, weight, right? So it has some methods like bark, eat, sleep, run, right? So a dog is your object, right? Similarly, you can say TV. TV properties like brand, screen size, resolution, smart or not. You can turn on TV, you can change channel, you can volume up, you can turn off this, turn on, turn off, change channel, volume up, volume down. One more you can add, volume down. So ultimately you are trying to create real life object with these properties. And how you will define this? You will create a class will have all the definition, and you will create object from this class. How? I will show you, don't worry. Right, these just not focus on this right now, it will be confusing. Okay, uh, let me know till now if you have any doubt. Right, is there any doubt till now? Forget about this one, this is coding part. I don't want to focus on coding right now. Understand the real world scenario, how in real world we understand this thing, right? Okay, right, so there is fields and properties, right? So fields and properties are same thing. Fields, properties, attributes, these are same thing. Now if you can remember from database, right, now I'm shifting to database. Why? Because ultimately sorry, just a second, let me create this again. Okay, fields, properties, attributes, these all are same. Now why I am creating a database, right? Just to explain you, right? Suppose you have a phone, right? For example, brand name is Apple. Okay, and model, right? You will have a model, brand, and color, and your battery, and maybe other features. Now are you able to recall? This looks like a table, right? So ultimately class, whatever class you are creating, from class we are creating objects. These objects are representing real life entity, and ultimately we save this data into database. If you see from Django point of view, or from, this is called ORM, object relation manager, right? Or object relation mapping. We try to map our object to table. So some people don't understand this object scenario. They get to understand that they take so much time, or either they do mug up the things. So you can just think of this as a just as a blueprint. We will create a blueprint of that, or a metadata of that, just like we create the table. When we create the table, we define its schema. Same way we are defining objects using class. All the definition will be in class, but in case of here we keep its metadata, right, to understand the table. The same way we are doing here, right? The same way you are saying these are attributes, fields, property, or column. Same way we are saying here properties, attributes, fields, right? We can't say column here. We can't say column because column terminology used here in database, not here. Ultimately our goal is to create some real life entities, and how we will create? With some definition. Definition will be inside class, and this class will have properties and methods. But each object, right now this object is your Apple, right? You can say this Apple brand phone, right? Now after that, suppose I have Android phone. For example, I have purchased which one is this? Okay, let me do Redmi, right? Redmi or MI mobiles, or maybe you can use OnePlus. So OnePlus entries, suppose we are doing here, right? So OnePlus will have its own features. So each object like OnePlus, Redmi, Apple have their own values, own state. So that is why these objects are independent, and these are predefined values which are defined in class. Right, let me show you how we can create. Let's try to create this class. Okay, we will try to create this class. Like we will have brand. Okay, we will have brand, we will have model, we will have black, not black, color, and we will have battery, right? Okay, let's go. We will try to create one class. In Python we use class keyword, right? Suppose I'm creating a class phone, right? And here we need to use one concept called constructor. If you have studied C++, you will be aware of constructor. Constructor are used to create the object, right? Init underscore underscore. I think you are aware of init, right? Init underscore init, right? This we used in modules, right? But here we will use to initialize the object. Here init underscore init underscore underscore. It is a function, and in class each function or each function is known as method, right? But this is a default keyword that will be go inside the function argument. Self means itself. Self means this object. When we create the object, then this self is act as that object. Now in phone we have certain property, like for example brand, we have model, and we have color. For simplicity I am taking these three, right? We can take more properties also, right? Now I am writing self dot brand. Self means, now let me tell you, self means itself. Self means object of this class, okay, will get this value brand, right? Similarly self dot model equals to model, right? Self dot color means color of this object, right? Then color. This is your constructor, right? Now we will have some functionality also. If you can check here, we can call, we can do text, and suppose we can take photo, right? Okay, I am taking only 3-4 simplicity purpose. Now again def, you know, we are creating function. The function name is call, right? Now it will, by default it will have self. When you use self inside the parenthesis as argument or as a as parameter, then it is known as method. If this self is not there, then it is considered as function, right? Self is telling that this is inside the class, right? Now I am writing a simple print. I am not doing anything, I am just writing not to call somebody, right? To call somebody, simple. Okay, now suppose I am creating another method or action, right? For example text, right? Text will again have self comma send text, right? And here I have text. Text means whatever text you are send message, right? And here is your message, right? Suppose you have another action, take photo, okay, take photo, and it will again have self is indicating that it is a method of class, right? Now print picture taken, right? Okay, now this is your class. We have a constructor to create object with these properties. So let me write here, this is constructor and these all are attributes, right? Or you can say your properties, right? And here these are your methods, methods or actions, or you can say behavior, right? Okay, and these are 4. Now this is your blueprint, or you can also write this is a triple quote, right? Just like we write in function, we can also write here phone class, right? And if you want, you can write the description. I'm not writing. So if I run this now, the class is created. Now if I want to create object, I will create object using class name, and I will define all these three things, right? Suppose brand name is Apple, okay, and model name is 16 Pro, right? I think we have 16 in market, right? 16 Pro. And what else? Color, suppose silver color, right? So this is your Apple. I am saving this into Apple variable. Similarly, I am creating OnePlus, right? OnePlus, okay, phone, and the brand name is OnePlus. Sorry, OnePlus. Anyone can tell me the model name of OnePlus? Any model name? Anyone? Any model names? Suppose ABs. 13R. Okay, great. So now I'm running this. Now you can see I have created object. Now if I print Apple, you can see main phone. It is a type of phone, and if you check its data type, right, using type function, you can say phone class, right? Okay, so basically what is happening, you are creating your own user defined data type. Now phone is your own data type. Now if you want to see Apple, if you want to see its brand, right, how you can write Apple dot brand, right? Now you can see it's Apple, the brand name is Apple, suppose, right? Now Apple dot model, right, and Apple dot color, right? If I run this, you can see Apple 16 Pro silver. So these all are properties. Now suppose I want to perform some operation like call, to call somebody. Now if I will do Apple dot send message, send text, call me after some time, okay, phone object has no true, okay, not send. Now you can send message, call me after some time, right? Take photo, suppose I want to take the photo, Apple dot take photo, picture taken. You can see this function got called. So if right now we have not added actual functionality, we have just written the print function. So ultimately this class is blueprint. When you are creating class, no memory is allocated, but when you create this Apple, this will get the memory, this will take the memory. Why? Because you are storing these three values. This will take the space, not other one, not the class one. So class is your blueprint. Class, phone class, blueprint for phone, right? So it's a blueprint, and if you know how to create class, then you can create object using its class name, and you can define its property. And on these properties, when you create this object, this is object Apple small with small a, and you can get its attribute, and you can also call the methods. So this is the most simplest way of creating the class.